So, good evening, everyone. I'm Prableen Kukrita, working as a PhD scholar in IIT Tirupati. So, let's start the last class of this computer networks. So, last time we had done the MCQs and all, covering most of the remaining part. So, as I asked last time also, do you want the MCQs only of the remaining part to be covered, or you want the revision session today? Again, I'll ask the same question. Can everyone write in the chat so I can know about the everyone's? Okay, someone is writing MCQs only. What about others? You want revision class or MCQs? What about others? Okay, Aditya is writing revision. MCQs with concept explanation. Okay. Revision. So half of them almost are writing MCQs, whereas half of them are writing revision. So let's do one thing. Till 7 o'clock, as much as MCQs we can cover, we'll cover the MCQs part. Okay, yes, tell me. I think now it's fine, Aman. Aman, I think you were not present in the last class. There are some people which are regular like you. I think you have seen the recorded video, Aman?
Last Tuesday?
Yeah, no, Friday was an extra class.
No, I did not attend the Friday one.
Okay. Friday we have covered MCQs only with the explanation part, the remaining part of MCQs only.
Yeah, I will see.
So we'll cover the MCQs part, and then we'll go to the revision part. Just a minute. So these were the MCQs, as you guys know, that we have covered in the last class. Plenty of MCQs. The whole class was about the MCQs only. So let's start with the remain. Let's start with this topic only. Okay. Though we have done this. This is Aloha data link layer topic about Aloha back layer and all CSMA CD and the protocols. How to contact you after this session for doubts? Okay, wait a second. Fatima, I have written my mail ID in the chat, and for everyone, I have written this mail ID. Whosoever is having the doubt, mail me. I'll definitely reply. Okay. So, just a quick overview. So let's start again with the first MCQ only. What is the maximum channel utilization? Wait a second. I'm just starting so that we should cover this topic. What is the maximum channel utilization of pure Aloha? What is pure Aloha? Any idea? I'll go to the revision part. Don't worry. At 7 o'clock, we'll start the revision, as many of the students are saying about the revision part. 1A. What about others? Yes. Yes, absolutely correct. The pure Aloha, basically, it was the first one of the MAC layer protocol for the collision and all. And I'll say it was early network protocol, which is not used today for managing the access of the shared communication medium when multiple transmissions are there. As I also told you in the last class, I'm myself working on this CSMA CD, basically the collision aspects combining with the machine learning in my research. And talking about the pure aloha, it was developed in, I'll say, 1970s, and obviously the answer is 18% of the channel utilization. After that, we switched to slotted aloha. Pure aloha, it was a simple, basically, protocol which was used for the contention based when there was more than one to basically to manage the shared communication medium. Now, after that, we moved to slotted aloha. What is the answer? Slotted aloha improved. Obviously, when we moved to slotted aloha, it improved the maximum channel utilization. Any idea about how much? Absolutely correct. Please, I'll request everyone else to also answer. Answer in the chat box, like 2, as well as like question number 1, as well as the option number. So basically, slotted aloha, we were having the slots. Now we were basically time is segment. I'll say we have time segments which is divided into slots, equal duration of the slots, and each one is required to transmit a single packet within that slots only. That is basically the slotted aloha main motive, as well as, I'll say, synchronization came into picture. When we switch to slotted aloha. Advantages over pure aloha, obviously, I'll say the channel utilization was like improved from 18% to 36%. Now coming to next question. Yes, Aditya, you're correct. What does CSMA CD stands for? What is CS in CSMA CD? Easy question only. These are easier one only. Absolutely correct. Then we came to carrier sense multiple access, and CS here stands for CS carrier sense basically. What MAC protocol is used by Ethernet? CSMACD, absolutely correct. What is the MAC minimum Ethernet frame size in bytes? Absolutely correct. It's 64. Aman, it's 64. B basically, not A. What happens when a collision is detected? The transmission continues, error message is sent, a jam signal is transmitted, or nothing. Okay, one more thing I'll tell you here. We have here the 14 byte is header size, plus I'll say 46 bytes of data, plus 4 bytes of CRC. CRC, that is basically for error detection, cyclic redundancy check. Okay. What happens when the collision is detected? It's basically a jam signal is basically transmitted. Jam signal, basically it is sent to inform all the nodes basically that there is a collision. Which Ethernet standard supports 100 Mbps? Yes, this is question number 7. Which Ethernet standard supports 100 Mbps? The answer is basically 802.3U. I'll say It defines the fast Ethernet with 100 Mbps. Which topology does 10 base T Ethernet use? I'm going fast as we have already discussed these 10 questions. I'll go slow after these 10 questions and then we'll discuss in detail about the rest. As we have discussed these concepts in the last and we have done already. Okay. So 10 base T. Yes, absolutely correct. It's basically star topology. As basically, what is T? Can someone tell me what is T here? I told you in last class also. 10 base T means
Twisted pair.
Absolutely correct. Both Krishna and Aman. It's basically twisted pair cabling in star topology. Obviously, star topology is basically where we have hub at center. What is back-off algorithm used in Ethernet? Linear back-off, round robin, binary exponential back-off, and random uniform back-off. Absolutely correct. It's basically binary exponential backoff. That only we discussed in the detail, like how it actually happens. Like we were discussing the same thing. Suppose I have 3 clients, or I'll say I am referring to 3 devices here. Clients means devices. I can use I'm using interchangeably about the devices as well as clients. And suppose I have the window size 0 to 16. This is the starting window size I'm using. Now, what is happening? Like they'll randomly choose a number from this. Suppose it chooses 8. Suppose it chooses 7. Suppose it chooses 9. Now, who will transmit first? Any idea? This was a window size. They choose a number randomly. Now, who will transmit first? It is a mechanism basically, how basically the transmission happens, how the contention happens. What I mean to say contention, who will contend first? Whose turn is first? Now they both are standing. They both will wait. Both will wait for these three will wait. These three will wait for the random time. How much time? They have some window size. They randomly choose a number from them. Now who will basically transmit first? Any idea? Yes. Yes, Aman, Krishna, Naveen, Aditya, yes. Or anyone else? Any idea about it? Come on, am I audible?
Yeah, yes, madam. Maybe highest or lowest. I don't know which one.
What about others? Yes, Aman?
Not sure.
So basically, it's like I'm basically choosing a number from them. So now, like it's like a clock tick is there. 8, 7, 6, 5, 4, 3, 2, 1, 0. And when 0 is there, then only they can transmit. Here there is 7, 6, 5, 4, 3, 2, 1, 0. When 0 is there, then they'll transmit. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Now who will reach the 0 first?
C2.
C2. So C2 will basically transmit because it has chosen the lesser value. So obviously C2 will transmit. Now this is the back of time they're waiting for. Now suppose they choose the same number. Now what will happen? Any idea?
Again, collision restart.
Collision will happen. Now, any idea what will happen? C1 and C2, both C1, C2, C3, there was a window, they choose the same number, random number, and there was a collision. Now, there was a collision between C1 and C2. Now, what will happen? Any idea? Because they both transmitted at the same time. They waited for some time. They both transmitted at the same time. Now both of them will double their window size because the collision happened. Now, so that the chances of collision should be lower. Now their window size will be, now they'll choose like from this collision, like from this window, rather than from this 0 to 16. That is why we have the name exponential backoff, binary exponential backoff. Got the concept? Yes. Yes, guys. Should we proceed, or
Yes, madam.
maybe I'll show you my paper as well. Wait a second. That is also the same thing. Maybe you'll get the clarity. Though I can't open it, the PDF form, because I'm not at my college. It can be opened by the college Wi-Fi only, IEEE. Though I can show you from this document only. So you guys have worked on overlay for working. Someone is working on research work, or anyone? Paper or something, or all of you are BTech students? Okay, today is the last session. Let's be somewhat interactive and let's discuss. Yes. Okay.
This is your paper, madam. I have seen, madam, several students now incorporating AI machine learning into their traditional algorithms.
Actually, this is I'm working on machine learning with computer networks. Basically, it's federated learning. Though I'll not go in detail, maybe because it's out of scope of your curriculum.
Yeah, we understand, but you know, this has become a very calm. Whenever there is a randomness, when there is uncertainty, people go for machine learning models.
Yes, 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 yes. Though I'm using computer networks within machine learning, like when I have more than like two more than here I'm showing here, like I have more three clients. So three clients are basically transmitting together. Then there is a collision. Then they'll wait for some back off time, and like they'll wait for some back off time before transmission. And when there is a collision, like this 201, after 201, you can see this. This is basically they are waiting again for some collision time because their back of window is doubled. That is what I have shown. And this is the Markov chain in figure 4, you can see. So this is whole, I'll say, computer networks part. If you want to go in detail somewhere, you can you can go through this paper. So just I wanted to show you how this small part can also help in the research. Like contention matters. Basically, that is what we are doing. How the contention is having an effect. So though it's having an effect in machine learning also, how it's having an effect, that's basically shown. Basically the whole modeling, the mathematical part, whereas the simulation is shown in the paper. Though I don't want to go in detail because it will go out of scope. Just wanted to show how it will help you in the real life these experiments as well. Okay, let's go to the next step. So before jumping, okay, so you guys are from BTech only. Can you write in the chat what you guys are doing right now? Everyone? Okay, working as SDE. Where?
Oracle.
Okay, okay, okay. What about others? Okay. Retired IT professional. Okay, BTech CSC. Okay. Nice. So we have, I thought that mostly BTechs are there, but we have all categorized people, like someone working in corporate sector, someone with a retired IT professional, teacher, BTech. Okay, let's proceed. In Ethernet, which field helps in synchronization before actual data transmission? Yes, any idea? The first field, okay. Okay, yes, that is preamble. That is the first field which we said. What is the role of SFD field in Ethernet? Denote frame end indicates the beginning of the destination MAC address, marks padded data, denotes CRC check. What about others? Absolutely correct, Aman. Basically, it's starting of the frame delimiter. Basically, it's after the preamble when it is sent the beginning. It indicates the beginning. What is the broadcast Ethernet address? We have discussed already about the broadcast address. So I hope so you might know about this as well. I want everyone should answer. Absolutely correct. FF, colon FF, colon FF, colon FF. Which MAC protocol is connectionless? So basically, if I talk about the standard Ethernet, it is connectionless. MAC sublayer with no handshake, I'll say. Obviously, it's connectionless, there is no handshake. What sublayer is added in full duplex Ethernet or flow control? Yes, absolutely, Naveen, you were correct for the 13th one. Coming to 14th question. What sublayer is added in full duplex Ethernet for flow control? Yes, come on. Okay, 14th A, 14th C. So obviously it will be A or C mostly because we have two layers, basically MAC layer as well as logical link control and MAC control. The answer is basically MAC control here. It is introduced in full duplex for flow or error control, I'd say. Okay, one more thing. If like you have answered logical link control, maybe thinking that it is used for error control and all, error management and all. But this layer, I'll say, don't handle flow control. Though error management is there, it deals with identifying network layer protocols as well as the error management. But talking about the flow control, it is not responsible for that. Why is CSMA CD unnecessary in full duplex switched Ethernet? What do you think? What is the role of CSMA CD and how can we relate? Absolutely correct, because there are no collisions, so obviously there is no use of CSMA CD. So in full duplex Ethernet, dedicated links ensures that no collision is there. So obviously CSMA CD is unnecessary. Which encoding method is used in 100 Mbps fast Ethernet? Yes, come on. Yes, Saman, what is your question?
How would we determine which encoding method is to be used for fasting Ethernet?
Basically, if I say that for the fast Ethernet, like we have different encoding methods, as you might know that non-return to zero, Manchester encoding BCD, and 4B5B. If I talk about fast Ethernet, which encoding method is most predominantly used to maintain the synchronization and all, that is basically 4B5B. Here B basically, it's basically block coding scheme. So it is basically designed for, I'll say, mapping more bits and for the fast Ethernet connection.
Madam, for normal Ethernet 10 Mbps, which one is used?
Yes.
For 10 Mbps Ethernet, normal Ethernet.
Yes.
For normal Ethernet, which encoding is used?
So for the normal non-return to zero, Manchester and all other encodings are used. But if I talk about fast Ethernet, then we mainly use this 4B or 5B. Other techniques can be used like NRZ or Manchester encoding and all. But if I talk about the fast one, then we prefer this 4B or 5B. It is used for 100 base like Ethernet. Should we proceed? Is it clear? Yes. Any doubts? Please mute yourself. Wait a second. I'll mute them. Shilpa, please mute yourself.
Collision detection, madam.
Okay.
Okay.
Factors reduce Ethernet efficiency. This is a logical question. Yes. What do you think? Long frame, small frame. Yes, the answer is D. Naveen, basically with the small frame size. Why with the small frame size the Ethernet efficiency is reducing? Because we have to do more frequent contention, and obviously with more frequent contention, the efficiency will be reduced. Which feature in the fast Ethernet allows dynamic speed negotiation? The name itself is telling us. Yes, absolutely correct. Auto negotiation. Most of the names will itself tell the answer. It will allow the device, basically, they'll agree on the best operational speed or best operational mode. And then that was the auto negotiation feature we basically used there. In switched Ethernet, how does the switch operate? Broadcast to all, forward based on the IP address, forward based on the MAC address, forward using the routing table. Yes, come on. 19. Yes, absolutely correct. So basically, we are basically here forwarding based on the MAC address, which uses the MAC address to forward the frames to the correct port. Why are collisions completely avoided in switched full duplex Ethernet? I think this is simple only. Okay, one more thing, okay. 20. Absolutely. Why it's MAC address and why it's not IP address? Any idea?
Because IP address is used by routers, madam.
And switch is which layer?
Which is MAC.
Data link layer.
Link layer.
And obviously till that time we have MAC addresses and not in the network layer we usually have this IP addresses. So here we are basically switch looks up to MAC addresses. rather than the IP here. It maintains the MAC address table for the physical fields. Coming to the next topic, what is the purpose of flow control in data communication? I want everyone should participate. Yes, Naveen, participate in the chat. Aditya, Naveen. Absolutely correct. To regulate data transmission, obviously, it's flow control. Eliminate the other options. Obviously, it's not to detect the error, not to encrypt the data. Basically, flow control is ensuring that sender shouldn't send that much of data so that it shouldn't overwhelm the receiver, and basically to prevent the overflow, I'll say. Which mechanism is used for error control in data link layer? Simple only. We have done many questions related to that. Many questions. I mean, rather than saying many questions, obviously many numericals also we have done. Absolutely correct. ARQ, I'll not explain that. In stop and wait ARQ, again, I'm jumping to this ARQ thing. We have already done this in detail. In stop and wait ARQ, what is the maximum number of unacknowledged frames? Very simple if you have attended the classes. Absolutely correct. It's 3B. Basically, it's stop and wait. Only one frame can be in transit. In stop and wait, we'll wait, and then again the other one after the acknowledgement. Other one will be sent. What happens if the acknowledgement is lost in stop and wait ARQ? Receiver resends it, the sender ignores it, sender retransmits the frame after timeout, or receiver discards the connection. What about others? If you have seen the watched the class, attended the class, you might know the answer. Absolutely correct. If acknowledgement is lost, the sender retransmits the frame after timeout. What technique combines data transmission and acknowledgement? Absolutely correct. 5C, piggybanking. Which ARQ protocol allows multiple frame in transit before acknowledgement? This we have already done in detail. That's why I'm not discussing. Absolutely correct. Go back and in go back and ARQ, what does the receiver do with an out of order frame? Buffers it, accepts it, send it to the upper layer. Absolutely correct. Discard it. Discard the out of order frame and expect for the basically expected one. Wait for the expected one. What is the size of the receiver? Window size in go back in equal to the sender window, one frame, half of the sender window, or unlimited? Is it one frame or is it equal to the sender window? Yes, come on. Think about it. Basically, it's one frame only. It's not about equal to the center window. In go back and receiver basically accepts only the next expected frame. And if it is arriving out of order, obviously we have seen that it will discard it. It was SR protocol. You are confusing. Which control variables are used by sender in go back and? Maybe we haven't discussed. Yes, S, SF, and SL. So basically, S is the next sequence number to send. Can you tell me what is SL and what is SF?
First and last.
So first and acknowledged frame, and that is the last frame. What is the main limitation of go back and in noisy links? It is very slow. It presents only the damaged frame. It requires acknowledgement for every frame. It presents all the frame, starting from the lost frame. What about others? Absolutely correct. It resends all the frames starting from the lost frame. Which protocol is more bandwidth efficient in noisy environments? What about others? Everyone should answer. Absolutely. 11th B. Okay. 11th.
Oh, 11C.
Yes. It's selective repeat. That's why we came to the selective repeat, because obviously, if I talk about the go back end, it was wasting lot of bandwidth by resending even the corrected frame from the lost one. That's why selective repeat, basically it resend only the corrupted or lost frame, which by which we are basically saving the bandwidth as well. The answer is selective repeat. What is the size of receiver window in selective repeat? Always, always 1, equal to 2 raised to power m, equal to sender window, at most half of 2 raised to power m. Basically, it's window size is less than 2 raised to power m minus 1, which is at most half of 2 raised to power m. What does NAK signify in selective repeat ARQ? What is the full form of NAK? Any idea?
Negative app.
Negative acknowledgement. So acknowledgement not received, frame corrupted or missing, last frame connection ended.
Frame corrupted or missing.
Please can you write in the chat, because everyone is answering. So write the question number as well as the option number. But you are absolutely correct. It's basically frame corrupted or missing. Why is selective repeat ARQ more complex than go back and? It buffers all incoming frame. It uses checksum. It requires token passing. It requires ARP. Answer is simple only, because all other options are eliminated here. I'll say it buffers all incoming frames. What is the now coming to ARP? What is the primary function of ARP? Okay, before starting this, let's have a quick overview about ARP. What is ARP?
Address resolution protocol.
Absolutely correct. What is the use of it?
DNS name resolution.
Yes.
DNS name resolution, madam.
Name resolution. More explanation? Can anyone give? Come on.
IP addresses to MAC address mapping. The solution.
Absolutely correct. IP to MAC mapping. So basically, it works like if I know the IP address, suppose the server knows the IP address, so server will broadcast a message saying that whose IP is this, and whosoever IP is that device will basically unicast the MAC address, saying that this is my IP address. So basically, mapping from IP to MAC. It's basically used for the IPv4 communication, as we have seen that how it's basically being used for the IPv4, whereas for the IPv6 we have neighbor discovery protocol as well. Now coming to the question, let's see. Obviously, what is the primary function of ARP? Now I think you know. Yes, come on. Question number 1, what is the primary function of ARP? What about others? Absolutely correct, to translate IP addresses to the MAC addresses. Which layer of TCP/IP model uses ARP? Absolutely correct, between network layer and data link layer. Everyone please answer. What is proxy ARP used for? Yes, come on. The name itself is answering, to allow a router to respond on the behalf of the another host. So basically, proxy ARP, it allows, I'll say, communication across subnet masks, or though it's not being used that much in use now, or I'll say it will answer the ARP reply for the other networks. To allow a router, the name itself is saying I am being the proxy. I am here to answer. It is allowing the router to respond to an ARP request on the behalf of the another host, which is not on that local network, and the host will think that that person is in the same local network. Can someone elaborate? You got the concept? Yes. Where it is used? Yes, someone? Can you elaborate about proxy ARP?
Maybe when the other hosts network cards are not there, or or the network is down.
It's like the router pretends to be the destination host. That thing is clear. Like when responding to ARP queries, it's behaving like I am the destination host, though it's not the destination host. It will basically forward it to the other one, which is not in the network. And the host will think that this is in the same network. It is in the same local network as mine, basically. That is how the proxy ARP works. So instead of ignoring the request, it's basically replying with its own MAC and it's forwarding the packet. You got the concept? Should we proceed? Which protocol is now considered obsolete and replaced by BOOTP and DHCP? What is DHCP?
Dynamic host configuration protocol.
So I think you guys know about DHCP. I have told in many classes about that. And BOOTP, I'll say it is a predecessor of DHCP. So which protocol is now considered obsolete? Okay, no, it's RARP. Any idea, anyone? What is the difference between ARP and RARP?
Yes, so RARP is reverse ARP.
So basically,
Back to IP.
absolutely correct. So why, obviously, why not ARP? As you answered ARP, why not ARP? Obviously, like if we know the host name, then it's giving us the IP address. That is what DHCP works. So that is what RARP also basically giving the MAC and IP is returned to us, which is now replaced by DHCP. The BOOTP is also replaced by DHCP now. What is stored in ARP cache table? IP to hostname mapping, MAC to hostname mapping, IP to MAC mapping, or ARP packets? I think it's simple if you know the concept of ARP. Absolutely correct. IP to MAC mapping. That is what ARP is there. IP addresses to MAC addresses, and we have this cache table so that we can speed up for future resolutions. We don't have to ask, so that's why. Which field in ARP packet identifies the protocol used? Protocol length, hardware type, protocol type. I think the name itself answers the question. That is protocol type. Which MAC address does proxy ARP respond with? So basically, it's its own MAC address. That is what proxy ARP, how it's working. Yes, absolutely correct. How it's working. So when we are asking for the IP, it's responding with when we are saying whose IP is this, it's answering with its own MAC address. Basically, saying that I am having the proxy of the another destination host. I can say. In which of the following scenarios is proxy ARP useful? DHCP assignment, firewall fault filtering, connecting VPN clients to LAN using the same subnet, Ethernet switching. This is somewhat how you'll understand more about this proxy ARP question. Yes, anyone? Absolutely correct. Connecting VPN clients. I want everyone should answer. I think Aman has answered. Aman, can you elaborate how? Aman and Naveen, any one of you?
Because proxy ARP will respond with its own MAC address, so the sender will think that it is communicating within its own subnet while it is actually communicating with other subnets hosts.
So yes, absolutely correct. Proxy ARP here, it is useful when a host is on different, I'll say physical network, but it needs to be appeared that it's on the same subnet. So a router which is running the proxy ARP, it can respond to ARP request for the remote client which is not there with its own MAC address. So that is how it is tricking the host that, okay, the remote client is directly reachable, though it's not directly reachable. It will answer it as it is on the remote subnet or other subnet, remote client, basically on the another subnet, but it is pretending to be on the same subnet. What happens if ARP cache contain an entry in pending state? The packet is dropped, the packet is sent immediately, packet is queued until MAC is resolved. Some of the answers it's like you can get from the question itself. Okay, ma'am, where can I get these MCQs? I'll basically upload on the drive. I forgot to upload the last. Okay. Tonight or tomorrow morning, definitely I'll upload all these this PDF as well as the remaining notes of the previous lectures. I hope so. You're having the drive link. Yes, the answer is 9C. The packet is queued until MAC is resolved. What is the purpose of boot P? Yes, anyone like any doubts? Okay. Okay, drive link I'll share at around, okay, during the end of the end of the lecture I'll share with you guys. What is the purpose of boot P? Okay. Absolutely correct. Provides IP configuration to the clients at the boot. It assigns IP addresses, boot file names to the clients at the boot time. So, anyone, what is the full form of this boot P? Basically, it's bootless. Bootstrap protocol. So, though it's not being used now, it was used in the earlier times. So, obviously now DHCP is used here. Earlier, I'll say, I think it was used when we don't have the IP addresses also. It was sent at the data link layer and all that process. The process used to happen there. Which transport protocol and port does boot be used for the clients? I don't think so though. This port numbers and all will come. I don't know the pattern, but I don't think so mostly. I'm not saying for sure, but mostly more logical questions will be there. How are the assignments more of logical or cramming part? I haven't seen. Yes, it's basically UDP port 68. Boot P client uses UDP port 68 as the server uses the 67 port, I'll say. Which field in boot P message indicates its client request? It's basically operation code 1. It denotes the boot request message from the client. What is DHCP primarily used for? I'm not going to that details for this 12th question. I'm not actually explaining because it's just the cramming one. Let's go to the more logical one, the questions which will appear in the exams as well. So what is DHCP primarily used for? We have discussed lot of time about DHCP. I hope so that you should answer yes, absolutely correct. Dynamic assignment of IP addresses and network configuration. What does DHCP use to lease an IP addresses to client? It's basically ARP table. Oh, sorry. What does DHCP? It's basically the least time only. DHCP basically assigns the IP addresses, I'll say for temporarily for the given least time. What kind of messages does a new DHCP client send first?
DHCP has this time limits like 50% lease time, 87.5% lease time, after which it starts for renewal.
Yes, 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 yes. What kind of message does the new DHCP client send first? Basically, it's DHCP serve discover. So DHCP client basically first broadcast a discover message so that it can know. Absolutely correct. It can know whosoever are the available, I'll say, servers there. Okay. So which layer of the OSI should we proceed or should we go to the revision part? I want that MCQ should be solved. For the revision, I think you can go to the previous lectures as well. But obviously, we can, as many of MCQs we'll solve, it will be better for you for the preparation as well. For the revision, you can go to the recorded videos. We are having the recorded videos, but MCQs we haven't solved it much. So let's go. Which layer of the OSI model does the bridge operate at? Yes. What about others? I want everyone should participate.
Madam, typing is very slow.
Okay. Slow speed or slow?
No, you have to put a cursor, click, and type. No, the rate at which you are going speaking is faster.
Okay, okay. I'll wait. I'll wait then. I'll wait. I'll wait. Absolutely correct. Data link layer. We all know about this bridge operator at layer 2, data link layer. Which protocol is used to prevent loops in the switch network? RIP, STP, ARP, or DHCP? I'll wait. Don't worry. I'll not be that fast. Absolutely correct here. That is spanning tree protocol, STP. So basically it prevents the broadcast loops. So that basically for the redundant path, preventing the redundant paths and all, biologically blocking all the redundant paths in the LAN. What does VLAN criminally separate? I'll come to this VLAN. First of all, answer this, then I'll come to this VLAN. IP domains, routing table, broadcast domains, or collision domains? Yes. So basically, the answer is C here. VLANs basically segment the broadcast domain. What they are doing the logical grouping of the devices regardless of the location part. What is VLAN, first of all, before jumping to this MCQ? What is VLAN? Any idea? So it's basically, I'll say, logical segmentation of physical network. I'll write it and then explain. What is the main purpose? What it is doing? It is allowing the devices which are in different location to communicate as if they are on same LAN. Any idea what I have told you? Can someone explain me more about this VLAN? I've written a definition. What it is doing is, it is basically, yes, come on. I want the answer first from you, then I'll tell you.
Madam, how is it connected to VPN, virtual private network? Because it's similar concept, it looks like.
What do you
VPN.
guys think? What about others? What do you think? Is it like VPN? I want the answers today from you guys only because it's the last class.
What is the question again? Can you repeat?
First of all, can you tell me what is VLAN? And as one of the person has asked, what is the difference between VLAN and VPN? Like, are they different?
In VLAN, we put tags on the packets or frames. So it means as if like distant hosts are working in the same subnet. Like they could be geographically separated, but
What is VPN?
VPN means like your IP is shifted to some other geographical location. It would be layer 3 and actually it's layer 3, but there is
Yes, ma'am. VPN is at layer 3, whereas this one is at layer 2.
Absolutely correct. I think you guys have answered it correctly only, as I have also written. So VLAN is basically allowing so that the different devices in different location they can communicate and it is at layer 2 basically. And obviously we have VLAN tagging as well, as he has told that which is used for identifying this VLAN membership and all. And directly they can't communicate without the devices in different VLANs basically can't directly communicate. This is used for network segmentation, traffic management and all. Okay. What does VLAN tagging work? How does VLAN tagging work? Yes. Just a minute, I'll come. Just give me a minute. Or see this 4 to 7 question and solve it. I'll come in a minute. 1 minute.
Madam, share the screen.
Yes, let's proceed. How does VLAN tagging work? As we have used the word VLAN. VLAN tagging, how does it work? Yes, absolutely correct. It basically uses IEEE 802.1Q to insert VLAN IDs into frame headers for the routing purpose. Which IEEE standard defines the wireless LANs? Absolutely correct. It's 5C. Which topology is used in infrastructure-based LANs? Absolutely correct. It's basically star topology. What is the purpose of RTS or CTS in WLAN? What is RTS, CTS? Yes. Can someone tell me?
Request to send
Clear to send and request to send.
clear.
So before transmitting, we usually send this RTS and CTS. Why we send it? You're somewhat correct, Aman, but just a minute, I'll come. Yes. So it's basically, though the answer can be to avoid hidden node problem as well. So it's basically avoiding detection collision, which is caused by hidden node problem only. Though I'll come to that. Which problem does the CSMA-CA aim to solve that CSMA-CD cannot?
One question, so why would it be detect collision? We avoid collision in CSMA CA, not detect it.
Detected. Yes, 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 yes. You're correct. You're correct. CSMA-CA, we do avoid it, we do detect it. Either it should be to avoid collision, I'll say, for RTS, CTS, or the answer should be to avoid hidden node problems. You're correct. You're correct in that sense. Okay. Which problem? That's why I told you that your answer can be correct only to avoid hidden node problem. Which problem does CSMA-CA aim to solve that CMS-CD cannot handle in wireless networks? Which problem does CSMA aim to solve? We can solve here collision avoidance. Collision detection is hard. It focuses on collision avoidance, as you said only. Okay. Why can't CSMA CD you be used in wireless LANs? What about others? Yes, absolutely correct. It requires simultaneous transmission and reception. Wireless devices can't listen while transmitting. So collision detection is impractical. In VLAN enabled switch network, which of the following is true? All ports are in the same VLAN. A host VLAN is determined by the IP address. VLAN membership is assigned to switch ports. VLAN exists only on router. Absolutely correct. VLAN membership is assigned to switch ports here. So basically VLANs are configured on the switch ports only, and the port is basically belonging to a specific VLAN, I'll say. Which type of VLAN assign membership dynamically based on MAC address? Absolutely correct. It's basically dynamic VLAN, which is using management software to assign VLANs based on MAC addresses. Which of the following defines a VLAN trunk? The name itself is suggesting what does trunk mean. Absolutely correct. A link that carries traffic for multiple VLANs. So trunk link is basically used between switches or routers so that to carry the traffic for multiple VLANs. Which interface space has the lowest priority in CSMA CA? Any idea? SIFS we know at the starting, then PFS and DIFS it's for like PCF and DCF, point coordination, distributed coordination, point how it is. Server will tell which client will basically transmit. DCF will they'll contain. They itself will basically transfer. Any idea which interframe space has the lowest priority? Yes, absolutely correct, Aman. EIFS only. So it is extended interference space. At the last, we have it, and it is used for error recovery and all, and it has the lowest priority. Which 802.11 standard offers speeds up to 600 Mbps using both 2.4 gigahertz and 5 gigahertz? Yes, anyone? So it's basically 802.11n. So talking about this, it supports the MIMO technology, or I'll say for the higher throughput and all. That's why we have this n basically, which is I'll say being improved. The improvement earlier we were having like 802.1a, b, and g, and now we have come to n basically. I think in 2009 or 10 we came up with this. So we have like multiple input, multiple output, and MIMO technologies over there. It was 802.11. N is the introduction of the MIMO technology, I'll say. Multiple input, multiple output for the higher throughputs and all. I'll say advancement over A, B, and G. So for the advancement of the wireless networking, for incorporating these type of technologies, for improving the range, greater reliability, higher data rates, we came up with this. What is the main advantage of using VLANs? Yes, this I think you may know about this. Absolutely correct. Logical grouping of devices regardless of physical location. What is the role of designated bridge in spanning tree protocol? Yes, come on. So the answer here is C. Basically, designated bridge. It has the low, I'll say, least cost path to the root bridge, and it forwards all the frames on this LAN segment. What is the function of NAV in CSMA? Network allocation vector. Yes, come on. Absolutely correct. It reserves the channel. Um, Basically, it helps in virtual carrier sensing by reserving the medium for the specified time duration. Which interframe space allows base station to issue beacon frame? What about others? Absolutely correct. It is PIFS, that is point coordination IFS. We have two types like point DCF distributed as well as PCF, that is point coordinated, and here PIFS is point coordination IFS. What does it happen? Like here the base station or the server basically gain the control. Like it will tell about the client. It will obviously not have collision. We will not have collision in DCF. Like suppose we have 3 devices, so it will tell which client will basically transmit first. So that is what PIFS means. Like PIFS, we are using in PCF basically, which allows the base station to issue beacon frames, which WLAN mode allows devices to communicate directly without an access point. Now I think you can answer this. Simple. We have talked about this mode earlier also. We don't need an access point. It communicates directly. Aman, in star topology, is there an access point? We do have hub, na? Am I correct, Aman?
Yes, ma'am. So
Yes, it's basically ad hoc mode. It's fine. So, here, obviously, we don't have devices from, they can connect directly without relying on access point. What is the function of max sublayer in 802.11? Easier only, very easy question. Absolutely correct. Handles access to the wireless medium. I think the part in data link layer, I think we have covered everything in data link layer. The main part, I think, in the data link layer, we haven't covered, that is hidden node problem and export. Uh, the other one is the exposed station problem. So let's have a brief summary. We didn't have the MCQs for that. Can someone tell me about hidden node problem and exposed station problem? Yes. Yes, come on.
hidden node is when suppose a host is starting, like it wants to send some data, but it doesn't know that when it is like beginning to send, some other or no like host also starts sending data. So because it is not aware of other hosts situation, it is not like they are not connected, right?
Yes. So absolutely correct. So two nodes, suppose A and C, here as you can see, they both wants to send the data to the third node, say suppose B, but A and C cannot hear each other. They are hidden from each other. They both think that the channel is idle, I'll say. They are thinking the channel is idle and they can transmit at the same time. But it causes the collision at B. That's what the hidden node problem do say here. Because here C is out of range as A don't hear, and node C also can't find the channel A as A is also out of range. So what is the solution? Can I say that RTS CTS is the solution here? Node A will send the RTS to the B will reply with the CTS. and we will reply to everyone with the CTS note. C who hears the CTS will keep quiet. It will get to know that okay, B is basically reserved for some other one. Can I say that? Is it clear?
Yes,
As
ma'am.
we don't have the MCQs for this, that's why I thought okay, for data link here, this part is remaining. Expose station problem. Can someone tell me about expose station problem? Yes. Aman? Yes. Any idea?
So it is like reverse of the previous one. So in this case, they cannot send back the response because each two nodes are thinking that the other one is sending, so it cannot send, and that is why they are stuck in the loop.
Yes. So B is sending to A, C is sending to D, but C is thinking that okay, B is sending, it can interfere and there might be collision. So C don't send it. But it's not the case if C will send to D, there'll be no collision because B is basically sending to A. So there'll be no interference here. So C is basically there is no need to back off from them, which is I'll say here it is basically underutilization of channel. We have that, we have the privilege to say, but the she is thinking okay, I don't have that privilege, there may be a collision, the transmission would cause a collision, but it is not the case. So RTS CTS can help here also. Think about it. Can I say hidden node problem? The cause of the problem is the nodes can't hear each other, and here they're unnecessarily differing that there can be a collision. Effect is here, the collision can be at the receiver end, here the channel underutilization, and yes, the RTS CTS can help in both the sides. Coming to the other part, the MCQs. Which OSI layer is responsible? Coming to physical layer now. Which OSI layer is responsible for signal transmission through media? Absolutely correct. Physical layer. Which of the following defines analog data? Absolutely correct. Continuous values. What is the function of modem? These are simple only. That's why I'm just going.
3 bit.
Absolutely correct. Converts digital to analog and vice versa. Baseband transmission is typically used in
हो रही है हाँ ऐसे कर ले
yes. Baseband transmission is typically used in absolutely correct LANs. So it's like they are using the entire bandwidth and it's commonly used in LANs. What is the difference between baseband and broadband? Absolutely correct. It uses single channel, whereas broadband uses multiple. Which device regenerates weak signal over long distances? I think in the very first class we have discussed about it. Absolutely correct. Repeater. Which of these are simple one only? That's why I'm not explaining. I'm hoping that everyone knows about this, that how the repeaters are the ones which are boosting and retransmitted with the weak or distorted signals. Which of the following defines attenuation? Absolutely, most of them have answered it correctly. It's basically loss of reduction in signal strength as we are basically traveling. The bandwidth of the composite signal is calculated as correct difference between highest and lowest frequency. Which type of the signal has a limited number of values? Correct only. Digital 0 and 1. SNR is measured in signal to noise ratio. Absolutely correct. Decibels. According to Nyquist theorem, bitrate depends on yes, come on. Yes, most of you have answered correctly. Some of you have correct answered. Like it's basically a number of signal levels. Anyone, you know the formula of Nyquist formula, like Nyquist theorem formula? Anyone? What is bitrate? Basically, it's 2 into bandwidth, where L is the signal level. So number of signal levels. Shannon capacity. The formula is used for. This is very famous formula which is used for. Absolutely correct. Noisy channel. Which encoding technique uses phase inversion of 1? I'll come to the encoding technique. Basically, mainly is Manchester and differential Manchester. I'll go to one of the numerical. Oh, I mean to say one of the question rather than saying numerical. Inversion of 1. The name itself is saying. Yes, absolutely correct. Your guess is correct only. If you have guessed it, if you know it's good. Maybe you have written the question mark. That's why I referred to as guess. I here refers to inverted, which means inversion for 1 only. Which encoding scheme always has a transition at the middle of the bit? I'll come to this Manchester, don't worry. Manchester, differential Manchester and everything. It's B only. By mistake, I told you the answer only. Which modulation technique shifts frequency to represent bits? The name itself is saying if you know the full form. What about others? Please answer, I'll be slow. Yes, frequency shift keying. It basically changes frequency for binary 1, 0 and 1. QAM is the combination of It's B actually. It's the combination of amplitude as well as phase modulation, not frequency modulation. Okay, which technique uses sampling and quantization of analog signals? Yes, come on. Absolutely correct. The answer is PCM, pulse code modulation. Delta modulation represents a signal using refer to the name delta. It's basically differential values. Which of the following is a type of analog modulation? Yes, it's 19C. Which type of multiplexing is used in fiber optics? Absolutely correct, 20th C. Though I have to go, what I can do is I can share this PDF, the remaining questions you can check, or maybe I'll tick mark the questions. I think these are the 50 MCQs. I think 30 are remaining. So I have to go, but I want that once you should know about this Manchester as well as differential Manchester, how to do it. So how I have just made like written it before only. So here, if I talk about Manchester encoding, Manchester, how we are representing the one here. Let's see. The one is like this, as you can see. This 0 is like this. I'm telling you because it's an important question which may come, like how to represent it in the for Manchester and differential. For differential Manchester, we have, I'll say, more than one waveform. For a 0, we have like this, and for 1, we have like this. So let's see an example quickly. Like suppose I have this Manchester. So how is the 1? 1 is like this. 1 like this. 0 like this. Again 1 like this. As you can see, 0 like this. Again 1 like this. And as I told you, differential Manchester, we are having more than one form. So we can represent it like this also and that like this also. If I have 1, I can represent it like this one or this one. Sorry. I'm sorry. Like this also, like this also. So if I have 1, I can represent it like this or like this. So this is how differential Manchester, like I have done. Maybe I'll also put this also with the MCQs, this notes, or maybe with the last week notes, I'll attach this as well. Yeah, I have to go, but I hope so your exam goes well. All the best for your exam, and I hope so we have done plenty of MCQs today as well. And if you like, when is the exam?
May 4th.
May 4th. Mail me if you're having any doubt in any concept in any MCQ as well. I'll reply. Please send the PDF MCQs. Okay, I'll send it. Wait a second. I'll share the drive link now only. I think anyone is having the drive link? I have shared it many times in the class as well. Though, just I'm sharing it. Can you guys access it? Though I have, I think, some MCQs like previously, which we have discussed in 4 weeks are put here. If possible, all sessions. Yes, absolutely. I'll put, though we haven't done MCQs in all sessions, we have basically understood the concepts, the notes and all. I'll put it for sure by tomorrow morning. And this video also I'll put it and on the YouTube channel. And you can, the other videos also you can watch there, the recording.
Ma'am, the Friday one is uploaded. Could
Yes,
you tell?
yes, it's uploaded.
Okay, thank you.
There also we have done MCQs only. How was the session? Any feedback? Though this was our last meeting. So thank you. I hope so. The sessions were useful for you guys. Were it useful?
Yes, very much, madam. So
Thank you so much.
purely based on the sessions, I am sure you can score at least 50-60%.
Thank you so much. Sudha, I don't know about that thing. Maybe you have to mail the NPTEL one. Thank you so much, Aman. So, Aman, you are in Bangalore branch of Oracle or where?
Bangalore, but currently work from home as well.
Okay. Okay, then. Thank you so much. Mail me if you have any doubt, okay? Okay, all the best, everyone. Thank you, class.